Hello everyone, my name is Kishan Agarwal. Today I'm going to present my concept video of data structures and my topic is applications of tree. Decision based algorithm is used in machine learning which works upon the algorithm of tree. So let us start with the trees, what are trees, and then moving forward to the decision based algorithm which is purely based on algorithm of tree. So tree data structure. A tree is also one of the data structure that represents hierarchical data. Suppose we want to show the employees and their positions in the hierarchical form, then it can be represented as shown. So data structure. Tree data structure is a non-linear data structure which is very essential and important data structure. So let us see the key points of the tree data structure. A tree data structure is defined as collection of objects or entities known as nodes that are linked together to represent a simulate hierarchy. A tree data structure is a nonlinear data structure because it does not store in a sequential manner. It is a hierarchical structure as elements in a tree are arranged in multiple levels. In tree data structure, the topmost node is known as a root node. Each node contains some data and data can be of any type. In the above tree structure, the node contains the name of the employees, so the type of the data would be string. Each node contains some data and the link or reference to the other nodes that can be called as children's. Next is decision tree classification algorithm. Decision tree is a supervised learning technique that can be used for both classification and regression problems, but mostly it is preferred for solving classification problems. It is a tree structure classifier where internal nodes represents the features of a dataset, branches represents the decision rule, and each leaf node represents the outcome. So in a decision tree there are two nodes which are decision nodes and leaf nodes. Decision nodes are used to make any decision and have multiple branches, whereas leaf nodes are the outputs of those decisions and do not contain any further branches. The decisions or the tests are performed on the basis of features of the given data structure. It is a graphical representation for getting all the possible solutions to a problem or decision based on given conditions. So let us see the classification algorithm. It is called a decision tree because similar to a tree, it starts with the root node which expands on further branches and constructs a tree-like structure. In order to build a tree, we use CART algorithm which stands for classification and regression tree algorithm. A decision tree simply asks a question and based on the answer, it further splits into a tree or a subtree. This is a basic decisions tree. We can see that here decision node is the root node and we have subtrees called decision nodes. Again, if there is a leaf node, we can say that it is the outcome. If it is a decision node, it will further have children's like a tree. Next is why we use decision trees. These are various algorithms. There are very various algorithms in machine learning, so choosing the best algorithm for the given data set and problem is the main point to remember while creating a machine learning model. So there are two reasons for using decision tree. First reason is decision tree usually mimic human thinking ability while making a decision, so it is easy to understand. And the second reason is the logic behind the decision tree can be easily understood because it shows a tree like data structure. So let us look at the basic terminology of decision tree. So root node is a form where the decision tree starts. It represents the entire data set, which further gets divided into two or more homogeneous sets. Next word is leaf node. Leaf nodes are the final output node, and the tree cannot be segregated further after getting a leaf node. Next is splitting. Splitting is the process of dividing the decision node or root node into subnodes according to the given conditions. Our next keyword is branch or subtree. A tree formed by splitting the tree is called as a branch of the tree or a subtree. Pruning. Pruning is the process of removing the unwanted branches from the tree. Parent or child node, which is the root node of the tree, is called a parent node, and the other nodes are called as child nodes. Next, how does the decision tree algorithm works? So in a decision tree, for predicting the class of the given data set, the algorithm starts from the root node of the tree. This algorithm compares the value of root attribute with the record real data set attribute, and based on the comparison follows the branch and jumps to the next node. For the next node, the algorithm again compares the attribute values with the other subnodes and move further. It continues the process until the complete process can be better understood using the algorithm. So let us see what are the steps involved in decision tree algorithm. Step 1. Begin the tree with the root node, say S, which contains the complete data set. So after finding, the next step is find the best attribute in the dataset using attribute selection measure, ASM. After selecting a attribute, we have to divide the S, that is root node, into subsets that contain possible values for the best attributes. The next step is generate the decision tree node which contains the best attribute. Final step, recursively make new decision trees using the subset of the dataset created in step 3, that is dividing the S into subsets that contains possible values for the best attribute, and then continue this process until a stage is reached where you cannot further classify the node and call the final node as leaf node. That means if continue the process, that is step 3, until you reach a leaf node in the decision tree. Let us take an example. Suppose there is a candidate who has a job offer and wants to decide whether he should accept the offer or not. So solve this problem using decision tree. Starts with the root node, that is the main attribute is salary attribute by ASM because it is a important attribute. So starting with the salary attribute, this root node splits further into the next decision nodes, that is distance from the office, which is another important attribute, and one of the leaf node is based on the corresponding labels. The next decision node further gets split into one decision node, that is cab facilities, that is the leaf node. So finally the decision node splits into two leaf nodes, accepted offer or declined offer. So this is how a decision tree algorithm works, which selects a best attribute to be compared, and finally work this process is continued until we reach a leaf node in the tree. Next is attribute selection measure, AST. While implementing a decision tree, the main issue arises that how to select the best attribute for the root node and for the subnodes. So to solve such problems, there is a technique which is called as attribute selection measure or ASM. By this measurement, we can easily select the best attribute for the nodes of the tree. There are two popular techniques for ASM, that is attribute selection measures: information gain, Gini index. These are the two important methods for selecting a best attribute. So let us begin with our first one, which is information gain. Information gain is the measurement of changes in the entropy after the segmentation of the dataset based on an attribute. It calculates how much information a feature provides us about the class. According to the value of information gain, we split the node and build the decision tree. A decision tree algorithm always tries to maximize the value of information gain, and the node or attribute having the highest information gain is to split first. It can be calculated using the below formula, that is information gain is equals to entropy minus weighted average into entropy by each feature. Entropy is a metric to measure the impurity in a given attribute. It specifies randomness in data. Entropy can be calculated as entropy is equals to probability of yes into log 2 log of probability of yes base 2 minus probability of no into log of probability of no base 2, where S is total number of samples collected and probability of yes and probability of no. Gini index. Gini index is a measure of impurity or purity used while creating a decision tree in the CART, that is classification regression tree algorithm. An attribute which with the low Gini index should be preferred as compared to the high Gini index. It only creates binary splits, and the CART algorithm uses the Gini index to create binary splits. Gini index can be calculated using the below formula, which is Gini index of 1 minus summation of p of j squares, where p of j squares represents the Gini index. Our next is pruning, getting an optimal decision tree. Pruning is the process of deleting the unnecessary nodes from the tree in order to get the optimal decision tree. A too large tree increases the risk of overfitting, and a small tree may not capture all the important features of the dataset. So therefore, we require a technique that decreases the size of learning tree without reducing the accuracy. That process is called as pruning, where our dataset tree will not be so long, too long or too large, and it cannot be too small, so accuracy is also maintained. There are mainly two types of tree pruning technology used. First is cost complexing pruning, next is reduced error pruning. So let us see one by one. First of all, advantages of the decision tree. It is a simple to understand as it follows the same process where which a human follows while making any decision in real life. It can be very useful for solving decision related problems. It helps to think about all the possible outcomes for a problem. There is less requirement of data cleaning compared to other algorithms. Disadvantages are also there. So what are the disadvantages? Disadvantages are the decision tree contains a lots of layer which makes it complex. It may have an overfitting issue which can be resolved using the random forest algorithm. For more class labels, the computational complexity of the decision tree may increase. Thank you.